Advanced Algebra 2, Unit 1A Study Guide. Now we're going to look at problems concept 2A. So we're going to look at parent functions and graphing transformations. So we'll cover problems 31 through 36. So on 31, what you want to be able to do is recognize the parent function, describe the transformation of these parent functions. So you're going to graph the function that's given, describe its transformation from the parent. So 31, it's g of x equals x plus 3. So that's a linear function. And what's happening is that is a translation 3 up. So we'll put that equation in our table, and we'll put in just negative, 0, and positive values. So you can pick any of those. I just picked a negative 2, 0, and 2. And if we put them in the equation, then we get 1, 3, and 5. So now we'll just draw xy axis and label those points and draw it. So we've got a linear equation that has been translated 3 up from the parent. 32, that parent function, that's in the quadratic family. So 1/2 x squared. So that's an a value, that 1/2, and that is a vertical compression. So that's going to make that graph wider. You can also call it a shrink, and by 1/2. So we'll plug in negative and positive values and 0. So when you take each of those values and square it and then multiply by 1/2, negative 2, you'll get 2. Negative 1 is 1/2, 0, 0. 1 is 1/2, and 2, 2. So draw your xy axis, label your axes and a scale, and then plot those points. And you should get a nice smooth parabola U-shaped curve that has been compressed from the parent by 1/2. Now g of x, so that's the absolute value of negative x minus 3, or negative absolute value of x minus 3. So that, of course, is in the absolute value function family. Two things have happened to that. So that negative out front is an x-axis reflection, and the minus 3 is going to translate that down 3. So now let's put that equation in our table, and let's just plug in some negative, 0, and positive values. So when you take each of those values, negative 2 to positive 2, and put them in the equation, so we take the absolute value first, then we make it negative, then we subtract 3. So we'll get those y values. Draw your xy axis, label it, and your scale. And then just remember that is a V-shaped graph, and it should be one that is reflected over the x-axis and translated down 3, which it is. Number 34, that is the parent function is quadratic. So 3 things are happening to that as well. We have actually 2 things happened to number 33. 34, we have an x-axis reflection, and we have a translation 3 to the left, as well as a stretch by 3. So if it's translated 3 to the left, my vertex is going to move to negative 3, 0. And then I'm going to plug in negative and positive values around that vertex that has shifted 3 to the left. That's like how I like to graph my parabolas. Notice that my y values, because those are even values around my vertex, that they are symmetrical. So I need lots of negative space here. So I'm going to adjust my axes and label my scale, and then plot those points. And I should end up with a parabola that's reflected over the x-axis that is narrower than the parent, and that has moved 3 units to the left. 35, so the table shows the speeds of a car as it travels through an intersection with the stop sign. Graph the data in this situation and tell which type of function would be best to model the data. Estimate the speed of the car when it is 20 yards past the intersection. So I notice that I need both negatives and positives for my x values, but only positive for my y values. So I'm going to adjust my axes accordingly. This is actually will be an absolute value graph. So I'm going to graph the points negative 140, negative 50, 20. You can see my scale. On the bottom, I'm going by tens, and on the top, I'm going by twos. And so I've got an absolute value graph. Now it says estimate the speed of the car when it is 20 yards past the intersection. So I'm gonna move over. And so my speed will be approximately 8. Your friend says 2 different translations of the graph of the parent linear function can result in f of x equals x minus 2. Is your friend correct? Yes, your friend is correct with the linear function. So from the parent, y equals x, you can have a vertical translation down 2. So just subtract 2 at the end. You could also consider that a horizontal translation to the right. If you look at the graph from the parent, you can see it happening either way.